Well, now we get to cover all the awesome stretching and the fun with Perfect Palette Picker. Welcome to Seti Astro. Continuing on with our tabs, we're going to do statistical stretch and star stretch discussions together. First, I'm going to show the UI layouts, and then we're going to talk about what they're doing, and then go into examples here. So for a statistical stretch, there's again a select image button, but chances are you've already opened an image on your current slot. There's a couple parameters here: the target median, whether it's going to be a link stretch or not, normalize, apply a curves adjustment, and then apply stretch. We'll apply the stretch. We also have a zoom in, zoom out, and fit to preview. And then very similar on the star stretch side, this will be for a stars only image. There's going to be a stretch amount, a color boost amount, and remove green via, well, SCNR or removing green is going to be the option. And then you're going to be able to refresh that preview. This did have a holdover, undo, redo, but we have undo, redo at the top now as well. So let's talk about what this is doing, and then we'll jump into an example. So you may or may not know, star stretch was my very first script in PixInsight, and that's what kicked off this whole thing, this whole big passion project. So what it ends up doing, and it's going to be the basis math for just a ton of stuff. Even my auto stretch is based ultimately on what we're seeing on the screen here. What I did was took a median transfer function, just the median slider on your histogram, right? And here's the math for it here. And I just plugged in what would happen if you slid that over to 0.25 or a quarter and reduced the equation. We got 3 times the target over 2 times the target plus 1. And I thought, what's the behavior if I just keep applying, doing that same stretch over and over and over again? So you do the stretch by pulling the slider to 0.25, you apply it, and then you apply it, and then you apply it. So the next round, you could plug in the 3 times the image over 2 times the image plus 1 back in for x up in our original equation, and m still a quarter. You could reduce this whole expression here to this 9 times the target over 8 times the target plus 1. And then you can feed this back again into that equation. And then we're left with 27 times the target over 26 times the target plus 1. And you can start seeing a pattern here. 3, 9, 27, those are all powers of 3. 2, 8, 26, those are 1 fewer than a power of 3. So the general formula, if you just want to apply this kind of a stretch in a continual basis, you're going to have 3 to some amount times our target image all over 3 to that amount minus 1 times our target image plus 1. So that is the core of star stretch specifically. So when that slider's set to like 5, that's going to be doing this median transfer function where you pull it down to a quarter 5 times. So that's really where that 5 comes from. The color boost, that's just a saturation boost amount. Nothing fancy there. But then for statistical stretch, we can take that equation, that 3 to the x times t all over 3 to the x minus 1 times t plus 1, and we could rearrange it. We could solve for x. So we could solve for what stretch we need to get a known value. So if we put in the current median value, what stretch do we need to hit a target median value? And this could be solved, analytically. It could be solved exactly. It's this nasty looking log of all this stuff. You don't need the 2i pi n. That's fine. All over the log of 3. It's kind of ugly looking, but that will be the exact solution if you want to set a target median of like 0.25 and you know the current image's median. You could actually use this result and exactly set the image to your target median. Now this does reduce down a bit after you get it in to this other equation and stuff, so that's pretty necessary. Computers don't like taking logs and exponents and stuff, so it does reduce down quite a bit. So you can see in the code after it gets reduced down, there's no more exponents or logs or anything. but it allows you to exactly set the image's median to whatever value you want. Now hopping back over into Seti Astro Suite here, now we know what the target median math is behind that. Linked stretch, now this is going to be for color images. If it's checked like this, it's going to stretch all three color channels the exact same way. That is very important if you've done like color balancing in the linear state and now you just want to stretch it into the non-linear state without changing your color balance. If you leave this unchecked, it's going to take each separate channel, RGB, and stretch them independently based on the statistics of their individual channels. Normalize image, that's going to just take our final image and divide it by the max pixel value, essentially setting the maximum pixel value then in the image to exactly to 1. So it doesn't leave any additional dynamic range on the table. It's going to fill up the whole range possible. This normally doesn't change the image a whole lot, especially if there's already bright structure in there, like stars or something, that are going to be darn near 1 after the stretch anyways. The curves adjustment, now what this actually does, and I could demonstrate it over here, is it's going to place 2 points, 1 point exactly on the median, and 1 point halfway down off the median to anchor this whole lower section. And then it's going to raise up this upper portion by that fractional amount up to the top in order to boost everything that's brighter than the median. And everything brighter than the median in the image is really where your signal lies. So in statistical stretch, when you're giving it a curves boost, you're bringing that upper portion that far up towards the top and all the way up at a 0.5. That would be taking this dot here and moving it off the linear line here halfway up the graph towards the top. There's some other control points in there that are mathematically defined to really kind of even out what it's doing, but that's the gist of it for sure. So let's go ahead and chuck in an example. I have my Eagle Nebula here, and we can pop open the histogram too to see what's going on. We can see that currently the median is 0.013. And if we leave the target median at 0.25, we'll leave everything else off and just click Apply Stretch. Now it's stretched the image, and you can see the median is exactly 0.25 now. So that is absolutely what it's doing. And you see the max is 0.996. Now if we click Normalize Image and reapply the stretch, now it took that image and moved that max up just that little tiny bit to 1. And that did shift the median just a smidge up off the 0.25, right? Because we divided everything through by the max. The other thing with statistical stretch is, so in this case, the Eagle Nebula, right? We have nebulosity filling out this whole image. So 0.25 is an excellent starting point here. If you have something small, like just a small galaxy. All right, I have an image of a galaxy loaded up here. Now it's fairly small, it's right in here. Now if we leave the target median on 0.25, the median of this image is just background. It's not nebula or galaxy or nothing. So the whole image is going to get really bright to the 0.25. So for small discrete objects like small galaxies, planetary nebula, small nebula, I recommend actually having the target median down at like the 0.12 range as just a good starting point. So let's give it an apply stretch. All right, and now we can see the galaxy is starting to get a bit brighter. The background is still fairly dark without it being overly white. So this would be a great starting point now for our image. And just to show kind of what this curves boost does, then let's give it a big curves boost and just reapply the stretch. And now we could see that the galaxy got much brighter, but the background didn't brighten at all. And that's because of how the curves boost is structured in there. The last thing to touch on for statistical stretch is the link stretch. So I've done a white balance and background neutralization. So I'd want to keep this as a linked stretch. Hit apply stretch. And now you can see my galaxy is neutrally colored. If I turn this off and now it's just going to stretch all the channels independently. Now I can click apply stretch, and now you can see it has this greener cast to it as it just shifted everything based on the individual channel statistics versus the overall linked statistics. So that's the difference between the two. Here is my unlinked and the linked. And now I have star stretch up with a stars only image. Everybody knows the math behind that now, they remember, right? So you know exactly what the star stretch amount does. We have the color boost amount, that's just an additional amount of saturation. And then remove green, sometimes when you're doing separate star stretching, especially with, and then there's also the remove green if you find that some of the stars do have a green cast to them. Really, you just gotta give it a go. So I'm just gonna click refresh preview, and it adjusts my stars up now. This was done with my refractor doublet. You can see that I do have quite a bit of blue fringing there, but we'll talk about Halo Be Gone in a little bit too. So now we've done statistical stretch, star stretch. It's about time we go over to curves utility and cover this tab. On to curves. So curves has traditional curves and hyperbolic mode. Under traditional curves, you can adjust the brightness or the K value, individual red, green, or blue channels. You could also work in lab space, so you could adjust L star, which is luminance, A star or B star, which are the green, red, or yellow, blue components. You can also adjust chroma or saturation separately. And I'll put a link on the screen if you want to look at my video on the difference between saturation and chroma. I think it's a good discussion. Over on the left, we have the grid for the actual curves. In order to place a point, you double click, and you can adjust the curves with that. Left click, right click will delete the point. Also, when you're mousing over the image, it will show you the RGB or the K value components of the actual pixel values you're at. When you are satisfied with how your image looks, you can click apply curve, and that's going to actually push that new image to the image manager to be used in all the other tabs. There's an undo button, but you also have the undo redo up here. There's the ability to save a custom curve. So if you have a really cool, lots of points, you got this defined curve that you use a lot, you could actually save the curve and load the curve with that. And then clicking over on the hyperbolic mode, again, you could adjust the various channels. You could also pull up the histogram from here, and you can control click on the histogram, and that's going to put your inflection, that's going to put your symmetry point on the hyperbolic curve for you. You can reset it, and then you have values for alpha, beta, and gamma. Alpha is going to be the amount of contrast, or the S shape. The more alpha, the more S shape it becomes. And then beta is the actual slope at the inflection point. So if you increase beta, it's going to increase the slope here. And then if you decrease beta below 1, you can actually get the opposite slope, which can allow you to do things like put a little bit of an anti-S curve in your S curve to really control the shape of your hyperbolic curve. Gamma is an overall stretch. And if you guys haven't seen the video on my hyperbolic curve, I highly encourage it as well. And then low point and high point protection. So below the symmetry point, you can protect that. It'll even it back out towards the linear line. And then same with on the high point side. And then there's a big reset curves button here to reset it all. There's also a little instructions here on how to do things if you need to do it. You could also control click somewhere over here, to set your control points, to set your inflection point via just clicking on the image itself. So lots going on with curves, a lot of different ways to manipulate your curves, even if you want to do crazy things like just adjust the A star component. You can see how that changes the red-green component, or the B star, which is going to be your blue-yellow component. But I think most people, kind of going off the bat here, they're going to mouse over. This area looks like our background's right at about 0.125. So you're probably going to set a point there, maybe lock in the background, boost your galaxy up a little bit like this, right? These are just standard kind of curves. Then apply the curve, and now no matter what tab you're on, that's the new image. And if you go to undo, you can see it did say undo the curves adjustment now. So it's in there. But if you haven't seen my video on my hyperbolic curve, I highly recommend you go do that. I go into a lot more detail on what's going on specifically, and then a lot of different examples too on how to utilize it. So the next tab to talk about is going to be the perfect palette picker, and this is going to be a fun one to talk on. So right now I have S2 data, O3 data, and HA data on Wolfram 134. Now over in the perfect palette picker, all my data is linear, so there's a linear checkbox. If you purposefully stretch it beforehand and get your non-linear images how you like them, you could uncheck this. But right now it's going to normalize them because we say it's linear data. You could load your H-alpha, O3, and S2 images either by slots or by files. If you have an OSC camera that you use the dual narrowband filter on, you could load it directly into this. No need to extract your channels or anything. So there's one for HA03, and then I have another one for S203. So that way, if you have used both an H-alpha 03 dual narrowband filter and an S203 dual narrowband filter, you could load up those as well. You're going to see a whole bunch of buttons down here. It'll make a little more sense when we populate everything. So I'm going to load H-alpha. I'm going to load it from a slot. I'm going to load it from the H-alpha slot. Then I'm going to load oxygen from the oxygen slot and S2 from S2. Now when those are in there, I'm going to say create palettes. And now here's all our options. So it does all the work. If they were linear, it normalizes everything. Like I said, you could have stretched these individually, stretch them how you want, and then uncheck the linear option. But you're going to have all these different palettes at your fingertip. There's SHO, HOO, HSO, HOS, OSS, OHH, OSH, OHS, HSS, then a realistic 1, which is built upon the same math that's behind the Narrowband RGB stars. A realistic 2, which is essentially at HOO, and then sulfur's mapped to yellow, and then a full 4x palette. And then to see that, all you got to do is click the button, and up here it's going to actually show you the full resolution preview. So we can zoom out and zoom in, see how that looks. So this is the 4x palette. Here's the traditional SHO. So this would take quite a bit of work, I think, working masks and things like that to remove or shift the greens to reds and work with magentas and stuff like that. And then there's going to be some interesting palettes that, just don't get used very often that may be really cool to try, right? Try something new. This is OHS, kind of that same feel, but now there's more like these other cool golden spots where there was blue in before. HOS has quite the neon colors to it, but it's just trying different palettes, right? Usually you never ever see these, so it gives you an opportunity even just to see what they look like if you want to use one. And then like here's a realistic palette. Just different things to try. And then when you find a palette you like, then just click push final palette for further processing. And it says final palette image pushed for further processing. What that does is it overwrites whatever slot you're in. So now you can see slot 0 here has our new combined image. So what I recommend doing is clicking a different slot, like an empty slot, like slot 5 for my case, and then click push for final processing. And then it'll have it pushed to the active slot, slot 5. And now you can continue on with curves or any of the other functions we haven't even talked about yet, but Perfect Palette Picker is just a lot of fun getting your palettes the way you want them. And then if you want to try something else, you want to load more images, you want to load different images, there's a clear all images button. Clears everything out, ready for loading new images, either from slots or files or new OSC images. Just set you up to go. All right, and to round out today's part of the definitive guide, we'll do Narrowband RGB stars. So this is a means of once you've extracted the stars out of your narrowband images, whether that's mono H-alpha 03 and optionally S2, or you have a one-shot color that was from a dual narrowband filter, and now you have dual narrowband filter colored stars. You could use that here too for select OSC stars in the image. I'm going to go ahead and select my H-alpha image from a slot, so very similar to Perfect Palette Picker. And then my O3 stars, and I do have S2 stars as well. And now we have the H-alpha to O3 ratio. Moving this further to the right will get you more yellow-ish looking stars, and further to the left will be more reddish stars on the red side of the spectrum. Blues are still blues. Enable star stretch is just the star stretch we already did. So this is perfect. You could have your linear stars, right? You don't need to have stretch your stars at all. And I'm just going to click preview combined image. And here's our stars. So these are stars from narrowband filters, and they just look amazing. There's blues, there's oranges, there's yellows in here. It just does a wonderful job of creating realistic star colors from the narrowband data. And I'll show you what the slider here does. Like if you go way over to the right, now you can see those goldens turn much more yellow, and now there's kind of like some greens and stuff going in there, maybe even some magentas. And if you're way over on the left, now the reds are like this deep, deep red, and those blues are more of a teal. So the default value of 0.3 was really chosen pretty carefully to make sure that the star colors look as realistic as possible and as true to life as possible for being narrowband data. And like I said, you could have an OSC image and put that in there. And then lastly, you could always push to the active slot. Make sure you're on a blank active slot. Perfect. And now you can hop over to curves. Now here's our stars. If you wanted to tweak the saturation or maybe the brightness, or even like Halo Be Gone or something that we'll cover in the next part of the video. Well, I hope this one was just as informative as the others. Please comment, like, and subscribe.